Go ahead, Francis.
Hey, thanks, everyone. So I'm just going to talk a little bit about kind of a new thrust of our project to gather more information about debris flows once they happen to better inform our probability models. So as you all are aware, when there's a storm coming, there's typically a forecast, and at the top here you can see the flood watch and the predictions of debris flows here based on the probability model that Dennis has created. And so what we'd like to do is to take the next step and to verify predictions of the debris flow probability model. So there are kind of three ingredients here that we need to do that. First, we need to create a hazard assessment and use the probability model to make a prediction. So we're going to predict the probability of debris flows in an area. The second thing is, then as rain falls, we need to collect that information to know what happened. And then finally, we need to know after the rain, what's the response? Was there a flood? Was there a debris flow? Or was there no response at all? And this is kind of the crucial piece. So Dennis has kind of painstakingly put together a database of over 1,500 observations of areas where there was rainfall and then there was some response. And I'm just going to walk you through some of the general items that he has in this table. So there's kind of basic things like the fire name, the year the fire happened. There's also location data, UTM, XY data. And then there's the time of the storm. Importantly here, there's a field called response. And here we have a 0 for no debris flow and a 1 for debris flow. And we want both of those responses. So we're just as interested in times where there's heavy rainfall and nothing happens as we are in times when there's heavy rainfall and there is a debris flow, because that helps us to understand very clearly what that threshold.
Good one. Yeah. Right. Okay.
Yeah, that seems really important.
But that would be the other thing that we could do. And like I said, I can have a.
I just want to remind everybody, please make sure that you have your phones on mute. We hear some conversations going on in the background.
In addition, from the rainfall, we have rainfall intensity measurements, like the 15-minute, 30-minute, and 60-minute rainfall intensity, as well as the duration. And then finally, we extract information about the location where there was an observation. So the size of the watershed, the proportion of the watershed that's burned at high burn severity, moderate burn severity, low burn severity, things about the soils, the erodibility of the soil. So that's kind of the information that we have right now for about 1,500 locations. So we'd like to expand that database. And again, just to reemphasize what Dennis already said, this work relies heavily on the quality of the data, not just the quantity. So really good understanding of where debris flows happen and don't is crucial. So here's an example of some information that's really great. This is from an email that Eric Bolt sent out, and it's extremely helpful information. So he lists, the fire location, the date of a storm, and what the predictions were in terms of rainfall, and then as well as the measured rain rate, and the names of the rain gauges used to measure the rainfall. They also note the impacts here, so high water flows in creeks and debris basins, no issues, so that's really helpful. And you'll see in the second one, mud and debris flow reported across Highway 33 for the road closure. So That's pretty helpful. That gives the general location, Highway 33, and that kind of leads to, I guess, a request for folks as you have observations. One thing that we'd really benefit from is really good location data. So location data ends up being crucial to tying everything together. That allows us to assign a spatial location to an event. So we can say what the rainfall was that caused a debris flow or didn't cause a debris flow. And it also allows us to get important information about the burn. Was it in an area of high, medium, or low severity burn? And also, what's the topographic information in the area? How steep was the slope? What was the drainage area, et cetera? So location information is key. And I'll just show you an example here of how we tend to tie this together. So what you're looking at is just a screenshot from ArcGIS, for those of you familiar with that program. And the color areas are subbasins, and they are colored based on the likelihood of a debris flow given a rainfall intensity of 24 millimeters per hour. So the warmer colors, the yellows are higher probability, 20 to 40%, and the more cream colors are 0 to 20% probability. And you'll see that in the upper left corner, I've sort of highlighted a subbasin and a segment of stream in particular. And so in the table that's inset in this figure, the very first item is called segment ID, so it's segment ID 312. So for example, if we have a known debris flow, if someone says, hey, we saw evidence of a debris flow and the location is at this latitude and longitude, what we can do is relate it to the probability that's predicted in this model that Dennis created, and we can relate that to a segment ID. And by doing that, here we take the observations full circle. We take it from, we started with some prediction of what the probability would be, and then we have a debris flow observation, and we relate that back to a segment ID. Every one of these stream channels in the probability model has a unique segment ID. So then we can relate the segment ID to important basin characteristics like the burn severity, the slope, et cetera. So that's how we kind of take all this information full circle and then continue to improve the probability model. So lastly, just to give you a visual of how we're going to ingest this information, some of you might be familiar with Pandas data frames, and you might know how flexible and easy they are to ingest data. So here's an example of a Python notebook. So the second box shows variables on the left, variable names like fire name, and then on the right there's values. And since this is our template, they're all set to NaN, but we would obviously fill these in. And so this is how we would ingest information about the storm, rainfall intensity, the response we see, and we can ingest single events or mini events. So if there was a rainstorm that caused nothing to happen, then we could have a zero debris flow response for many segment IDs in a area where we had a probability prediction. Okay, so that's all I have.